Lesson 21. Area and circumference of a circle. Here's the lesson objectives. We'll look at the content objectives first. Understand the relationship between the radius and diameter of a circle. Understand that the ratio of the circumference of a circle to its diameter can be expressed as pi. I think that's the first thing we're going to look at and see. Discover an expression for the area of a circle using the area of a parallelogram. Solve real-world problems involving the circumference of a circle and the area of a circle. The language objectives. Remember, you can say, or you should be able to say with the language, I can. So at the end of this lesson, you should be able to say, I can demonstrate understanding of the terms circumference, center, diameter, radius, and pi. I can summarize how to find circumference using the terms radius, diameter, and pi. I can read to interpret and compare models that relate the areas of circles and parallelograms. I can make conjectures about the area of a figure composed of circles based on a model problem. I can reason aloud with a partner or small group to determine if circumference can always be found if the area is given. Here are prerequisite skills. Understand the concept of area and perimeter. Evaluate formulas for given values of variables. Solve an equation for the value of a variable and find the area of a parallelogram. And these are the skills we've already covered, so you should know them. And here's the vocabulary for this lesson. Circumference. It's the distance around a circle. Center. A point inside a circle that is equidistant from each point on the circle. Diameter. The distance across the circle through the center. It has to go through the center. Radius is the distance from the center to any point on the circle. So if you look at diameter and radius, radius is half of the diameter. Pi, the ratio of the circumference to the diameter, represented by the Greek letter pi. This is the symbol of pi. Let's look at the learning progression. In grade 6, students, you guys, found the area of right triangles, other triangles, special quadrilaterals, and polygons. In this lesson, these skills are extended to include using the formulas for the circumference of a circle and the area of a circle. They also write equations to represent complex areas. Next year, in grade 8, students will be able to solve real-world and mathematical problems that involve the surface area of a cylinder and a cone, both of which have a circular base. That's very important. Moving ahead a little bit. It also helps prepare students for high school geometry when they will study and apply theorems about circles. Let's look at what we already know, or what you know. In this lesson, you will learn to find the distance around the circle and the area of a circle. Remember, you have the reference sheet, so you can always look at those formulas, and we'll see how they're being applied and how to use them. The first task, we want you to find the distance around each of these 3 circles. What is the relationship between the distance around a circle and the distance across the center of the circle? You're probably asking, how can I find the distance around each of these 3 circles? Well, let's look. Do not use this page, but I would use this page right now. Use a string to measure the distance around each of the circles and record that distance here. Circle A, circle B, circle C. All right. Then you measure the distance across the circle. Across. Let me show you what that looks like. Okay. You're going to go across the circle going through the center. All right. So I would go across here. All right. Making sure you go through the center. Record that distance for circle A, circle B, and circle C. Okay. Again, across, going through the center, and then across, going through the center. Well, that's the best I could do right here. All right. Divide the distance around each circle by the distance across it. And then record the quotient. For those who don't remember, quotient is the answer to a division problem. And then when you solve it, what do you notice about your answers to the last problem? And then we can talk about we can describe the relationship between the distance around the circle and the distance across the center of the circle. So if I were you right now, I would pause this video. I would do all these and I will give you the answers after you're done. Well, when I did this, I actually did this on a piece of paper, and that's usually what we want to do. But again, if you used this page, it should be somewhat accurate. So circle A was about 9.5 centimeters when you measured it around with a string. Circle B about 12.5, and circle C about 19 centimeters. And notice it's always about. And then you measure the distance across. Circle A is about 3, circle B is about 4, and circle C is about 6. So even if you weren't with those calculations, that's okay. As long as question C, for the most part, is about the same answer, which is about 3.1, about 3.1, about 3.1. I want you to think real hard. And I'm sure you've seen this before. Pi. What's the value of pi? It's about 3.14. See the resemblance? 3.1, 3.1. Okay, and that's where pi comes from with all circles. So every circle, if you think about it, what do you notice about your answers of the last problem? I mean, it's very, very simple. They're all about the same number. Every circle, when you take the distance around the circle, which is the circumference, and divided by the diameter, you will get about 3.14. And that's where pi comes in. And that's what question E talks about. Describe the relationship between the distance around the circle and the distance across. Okay, and if you divide the distance around the circle by the distance across the center, you get a number a little bit greater than 3. And that's where pi came in. So let's look at this, about finding out a little bit more about circles. For a polygon, we know that the distance around the figure is called perimeter. But for a circle, they don't call perimeter. They say the distance around the figure is called circumference, usually the variable c of the circle. A circle is the set of all possible points in a plane that are the same distance from a point called the center. Okay, this is the center right here, as you guys can see that. Okay, the diameter d, the variable d, is the distance across the circle through the center. There is a diameter. Okay, and it has to go through the center, from one edge of the circle to the other. The radius, variable r, is the distance from the center to any point on a circle, which is, again, half the diameter. So they're saying it below. The diameter is twice as long as the radius. So d, diameter, equals 2 times the radius. So whatever the radius is, you multiply by 2, you have the diameter. The ratio of the circumference to the diameter, is the same for every circle. Is represented by the Greek letter pi, read as pi obviously. There it is, right here. This is what you did in the previous page. If you multiply both sides of the equation by d, you get a formula for finding the circumference of a circle, and this is what you will see on your reference sheet. So to finding circumference of circles, it's pi times diameter. Since the diameter is twice the radius, you can also write the formula as circumference equals 2 pi r. 2 times pi times the radius. Because 2 times the radius is the diameter. So these are similar. They are the same. In real life situations, approximations for pi are more useful. The decimal 3.14 and the fraction 22/7 are approximations used for the number of pi to solve problems. Now let's see if you can reflect on what you just learned. Use your own words to explain how to find the circumference of a circle with a radius of 4 inches. Include a drawing in your explanation. So please do that. I would pause this video, solve it, and then again we will give you the answer. Well, hopefully you did this. So the first thing I'm going to do is I'm going to draw a circle. as you should always do that. And they give you the information. They say the circle has a radius of 4 inches. Remember, radius is half the diameter. Okay, so we're going to draw a radius. Use a different color here. So here's the radius. Okay, this is not drawn to scale, but I'm doing my best, which is 4 inches. Alright, if you remember how to find circumference, you have the formula. C equals 2 pi r. The reason I'm using this formula, I mean, you can do C equals as pi times diameter. Okay, we'll do both. But the reason I'm using this is because they're giving me the radius. R stands for radius, C stands for circumference. So then I'm just going to plug in the given information. So when we don't have the circumference, equal stays equal, 2 stays equal, pi, which is 3.14, stays pi. And instead of the variable r, I'm going to plug in 4. Or you can do 4 inches. Now basically we just do the math. 2 times 4 gives me 8. Right? Because of the commutative property of multiplication, we can multiply the numbers. Okay. And then you can do 8 times 3.14. And you will get 25.12. So the answer here for the circumference will be 25.12 inches. And it's about, actually, right? Because pi is about 3.14. It's an irrational number. And if you use this formula, watch, it's the same thing. C equals pi times the diameter. Well, if the radius is 4 inches, the diameter must be 8 inches. And there it is, 8 times pi, which just gives us the same value. Okay? So here's what they wrote. They said to find the circumference, because it says, explain it, use your own words. So to find the circumference of a circle with a radius of 4 inches, you can double 4 inches to get 8 inches for the diameter. Then multiply 8 inches by 3.14, just like we did, to find the circumference. Drawing should show a circle with a radius drawn and labeled, as we just did, 4 inches, or a circle with a diameter drawn and labeled as 8 inches. Hopefully that was helpful, and part 2 will be coming up soon.